Okay, so this is the Build Your Skills and Lesson 7, Part 2. So number 5, the following table shows the depth of water in a water tank that is slowly being filled. The tank is being filled at a constant rate. So basically, it's got a tank and it's being filled up. So to begin with, initially, it would be at 0 and 0. So at time 0 hours, there would be depth would be 0 centimeters. So what does that mean? This is a direct linear relation. Because we're going to start the graph at 0 and 0, or our table at 0 and 0, or our equation does not, or our equation will only have to be y equals slope times x. So here it is at 2 hours, 24 centimeters, 5 is 60, 7 is 84, and 12 is 144. If the data were drawn on a graph, what would be the slope and what does the slope represent? Okay, so slope is m, and because it starts at 0 and 0, we can just go y over x, which is also the same as rise over run. Oop. Okay, so m equals, we'll just go 24 centimeters divided by 2 hours. And our slope comes out to 12 centimeters per hour. And if you're confused how I got this unit, it's centimeters. There's the slash, the divide line. We just turn it on its side per hour. What does this represent? Like all slopes, it's the rate. It is the rate at which the tank fills up. Now, we're going to write an equation here that represents the relationship between the time elapsed and the depth of water. So what they're saying is, what is y? We know m. What is x? Okay. So for us, it would be y equals 12 times x. Now let's put in some words to make sense of y and x. X is the time, as it always is, and y is the dependent variable, the depth of water. So we just got to put depth and time. So depth would be how much water there is going to be equal to 12 times time in hours. And that equation there can solve for either the depth if you know the time, or the time if you know the depth. So calculate how long it would take to fill the tank if it was 360 centimeters deep. So we'll just put 360 here. There's our slope, and we're going to solve for time. Okay, so what we'll do is divide by 12 on both sides, because we have 12 times time. To get time by itself, we need this 12 out of here. So if it's being multiplied by 12, you have to do the opposite action on both sides. So the opposite of multiplying is dividing. This cancels. And now you have time equals 360 divided by 12. And we end up with 30 is our time. So 30 hours have passed if there's 360 centimeters in the tank. Okay, number 6. Karen worked as a gardener during the summer. The following table shows her earnings for 4 days based on the number of hours she worked. Now, of course, if you work 0 hours, you are going to make $0, which means a direct linear relation, which means y equals mx. Okay, hours will be our x, earnings will be our y. Again, time is always the independent variable, so it will be on the x. Now, the following table shows her earnings for 4 days based on the number of hours she worked. Now, draw a graph of the data. I've filled this in for you so that it's spaced out properly. And you can see I've got 0 to $150 all the way from 0 to 15 hours. Okay, so let's plot some points here. And make sure you have your ruler handy. So at 3 hours, $27. So if that's 20, right about there, about 27. 4 hours and 36. You're right about there. 5 and 45. Okay, so that's 45. And 8 and 72. Right there. Okay, that's looking pretty straight. All right, and I will connect these, and it should go through 0 and 0 because it's direct. So I could have put that in here too. I could have put 0, 0 as a starting point. And B, does the graph appear to be linear, and how do you know? Okay, the answer is yes. Okay, now how does the graph appear to be linear, and how do you know? The only way you can truly test if a graph is linear is if you check the slope. If the slope is the same all the way along, then we have a straight line. Now, looking at it, it sure looks like it's going to be the same thing. But there are some graphs where it'll look linear, but if you actually crunch the numbers, the slope might be off in certain places. So how are we going to do this? We're going to take the slope from 2 sections. We're going to do the slope from here over to 0 and right here. Because if we have the same slope between along the line here in 2 sections like that, that's going to tell us, yes, it's linear. So number 1, m equals, okay, so for the first one would be 27 is the rise, $27 over 3 hours. So our slope is 9. Number 2 is going to be 36 over 4 because it's 4 long. And there we go. They are the same. So yes. And how do you know? The slope is constant, or another way you could say it, the same, or consistent, would be another good word. So how much does Karen earn per hour? And if we look at what our slope was, this is $27 over 3 hours. So this is dollars per hour. Her slope is her earnings per hour. So she earned $9 per hour. Now D, write an equation that shows the relationship between Karen's hours of work and her earnings. Okay. So we're going to start here. Y equals mx. We know the slope is 9. Now let's replace y and x with words. Y, if you look up on the graph, is earnings. And x is time. So there we go. $9 per hour times how many hours you work should get your earnings. So E, how many hours does Karen need to work to earn $99? Okay. 99, $9 an hour times time. Okay. We got to divide 9 on both sides. 99 divided by 9 is 11. The answer is 11 hours. And that is the end of lesson 7, part 2.